Okay, we are going to be continuing our modeling matter unit that we had started in school, and we're going to be doing this in remote learning. So it's been a little while, so I just want to talk about what we've been discussing. We've been discussing uh, from the context of a food company, and we talked about what matter is, and it's made up of tiny little things called atoms, and the atoms combine into something a little bigger called molecules, but still very, very small. And I'm going to read a letter that we received, and it says, "Dear food scientists, customers are concerned about food products that contain red dye number 75. Some people believe that red dye 75 causes health problems in children. Good food production wants to make sure our customers are safe. We need to test the food coloring that's used in many of our products to see if it might contain red food dye, so we know if we need to submit it for further testing. Please determine whether our food coloring is a pure substance or whether it's a mixture. If it's a mixture, please determine whether red dye is part of the mixture. Sincerely, Lauren Harold, President, Good Food Production." All right, so they use a couple of words there, mixture and substance. And today we're going to kind of find out what the difference between those are and talk about how molecules can be different. And that's actually what the question that I'm going to have you guys answer is about. It's about how molecules are different and how they're the same, actually. So this is the red food dye that might, or the food dye that might be harmful, red dye number 75. So depending on how much water you add, it might be darker or lighter. This is the food coloring that Good Food Production uses in many of its products. We'll test to find out if it's a mixture that can contain red dye number 75. So it doesn't look red there, but that doesn't necessarily matter. So since we're doing remote learning, we don't have access to the supplies we need. I don't, you don't, you probably don't. I'm going to have you guys watch a YouTube video, which I'll post on Google Classroom, and that'll be a different. They'll be testing a different substance, but the idea is basically the same. They're instead of using food coloring, the person uses a dry erase marker, a black dry erase marker. But again, the idea is the same, and you can get the same information from it. But let's look at something that's part of something called a chromatography test. Watch what happens when they put a piece of paper towel in the water. You'll notice that the water gets absorbed by the paper towel, right? And it goes up the paper towel. By the way, feel free to pause the video at any time if you want to think about something or talk it over with somebody. I'll prompt you to do the same when I ask certain questions. So it's good. I want you to discuss it with somebody or think about it on your own if you're just watching by yourself. Doesn't really matter who, it's just getting your brain working. There's no right or wrong answers right now. So in chromatography, I use that word chroma meaning having to do with colors, and graph meaning writing, or basically it's a picture. Color, so it's basically a picture of colors. So it's a paper strip dipped into water, as we just saw, but in a chromatography test, the paper has a special test mixture in it. It's a chemical that helps basically helps the substance that you're testing or the material you're testing separate. So you're going to see this in the video. They have it set up in a similar way. So pause for a moment and make a prediction what you think will happen when you watch the video and you see this. What do you think will happen to, imagine you take the food coloring, or in the video's case, take the dry erase. What do you think will happen to the black dry erase mark on the chromatography strip? All right. So we're not actually going to do this, as I mentioned, but we are going to take a look at a different model before you watch the video. And basically we see each cup, we see 3 cups containing different substances. So I use the word substance there, and we don't know exactly what that means, so I'm going to explain that in a little more detail. So you're going to pretend to have some nanovision goggles to see really, really small things, which make things look billions of times larger than they actually are. So put on your nanovision goggles right now. And in this model, each piece of pasta represents a molecule. So the ziti on the left is one type of molecule, the macaroni in the middle is another, and the rice, or orzo actually is what it's called, is another type of molecule. So pause for a moment and think about what you notice about the molecules. All right. So let's think about the substances in our model, one substance at a time. Are all the molecules of this substance here in this picture the same or different? Pause. Okay, hopefully you notice that the macaroni, the molecules are the same, but between the 3 cups, they're different, right? So here's a key concept that you should know. All molecules of one substance are exactly the same, and they are different from molecules of any other substance. So a substance contains only molecules of one type. Remember, we're investigating these questions. How are different kinds of molecules different? How are molecules similar? So we can add a substance to our chart, and as we just noted in our key concept, all molecules of one substance are exactly the same. So an atom is the smallest particle of matter, a molecule is made of several atoms, and a substance is actually made of one type of molecule. Now, we could take all those types of molecules and mix them together to make something called a mixture. So mixtures are made of different substances and include more than one kind of molecule. Let's add mixture to our chart, and we see in the picture that a mixture contains different substances. Contains that one that looks like a panda or Mickey Mouse, and it also contains one with 3 atoms in a row. So different types of molecules, right? How could we separate the mixture in our model back into 3 substances? Think about that for a moment. All right, and then let's watch a video. If the person shakes that cup vigorously, notice that the mixture separates into all 3 different substances because they weigh different amounts, right? What was it about the molecules in the pasta mixture that allowed the mixture to separate when the container was shaken? Think about that. You could pause if you want. I did just mention it. All right, they're different kinds of molecules, right? Different substances. So we figured out that molecules have properties. Let's add that to what we've learned. Properties of molecule include shape and size. All right, so you're going to watch the video. Instead of doing the activity, you're going to watch the video of somebody else doing the activity. Unfortunately, we have to do it that way for remote learning. And you'll see you'll ask yourself, what happened in the chromatography tests? What colors of dye did you notice in the chromatography strip? And if you think about whether you think the dry erase pen was a substance or a mixture. All right? A substance or a mixture. And is it possible that harmful red dye number 75 is in the food coloring mixture? All right, then I'm going to ask a question, and this is what the activity that you're going to do is, how are different kinds of molecules different? How are they similar? So think about what ways that they're different from another and similar. If you want to re-watch the video, the answers are all in this video. You can do that. That's all I want you to do. How are molecules the same and how are they different? And the hint is that it could really be answered in just two ideas. Molecules are the same. Molecules are made of what? And then how are they different? They differ in blank and blank. All right, so you're not gonna fill out this page exactly, but you're gonna pay. I'm gonna provide you with a format where you could answer that question. All right, thank you.